Okay, so in the last session we discussed about the net introduction, and today we are going to configure that net. Okay, how to configure the network address translation? What is the use of net that we already knows? How many types of net that already knows? So here this side is our local area network side, and we have a two server. Okay, that is completely. Just a minute. I'll explain you what is actually we are doing to do going to do. Just a minute. Okay, so this is our completely uh, this side. This is our completely this side is a vein. Okay, and the the other side is completely a lane network. Just a minute. Am I audible properly?
Yes, we
Hello.
can hear you properly.
Yes,
Okay,
yes,
okay.
yes, yes, audible.
Yeah, great. Okay, so this is completely a vein. Okay, this is our internet. Internet we connected from one of the ISP. This is ISP link, and it is directly the link is terminated with the firewall. This complete part is a vein. Now this complete part is a lane. This is also a lane. Okay, this is also our own network. So here the normal users are sitting inside the the office. Okay, and here we are having some server room. Okay, there is one server room one, we can say server room two, we can say. So this is called in generally we are calling it a DMZ, this kind of scenario. Demilitarized zone. Why demilitarized zone? Because this server is accessible for the local users as well as the public user via internet. Okay, that is called demilitarized zone. Why demilitarized zone? Because there is always there will be an fear that any outside user can enter to our network, and there could be a chance that if the configuration is wrong, then they can manipulate our network and they can enter to our inside too. Okay, so we just wanted to allow access to the outside user which we want to uh, you know introduce, or which we want to publicly some anything like website or anything service which we want to allow that they can only access. Okay, so today we are going to do a uh, static net for inside users, this user for the to access the internet. At the same time, with the by using the static net only, will allow a outside user to access our inside. Okay, so start the configuration. Okay, so this R1, R2, R3, R4 is already exist, and R1 the configuration part is already there. This as usual we are doing right. So this is the configuration part. Okay, so R1 enable configuration terminal that whatever the IP we are having. Okay, that complete IP and the RIP I'm going to configure here. Okay, complete RIP we are going to configure here in our R1. So just go and do the paste. So whatever the IP 110, 172, 10, 20, 10, 20, everything is configured here, right? So IP interface brief. If you check, so IP interface brief. So IP interface. So IP interface brief. So what are the IP? 1.1, which is our that 0 by 0 interface. 101.1. So 101.1 is our this one, right? The lane side, other segment, okay? And 10.1, 10.2, 10.3, 10.4, and 10.5 is their upper side. Got it? Similar, we also configured show IP route RIP. So RIP has been configured, okay? So IP route, but it will not show now because there is nothing other like a packet exchange happen in through the routing. So just assume there is a route RIP has been already configured. Router RIP version 2, no auto summary network, whatever the network is having, that should be advertised with the RIP. Okay. Now we are going to enable that telnet and the SSH configuration into our that device. Okay. So keep doing like this. I will share this configuration with you post the session. Okay. By using this, we'll enable the telnet. By using this, we'll enable the SSH. By using this, we'll enable the HTTP service. Okay. Configuration terminal, host name. Okay, host name already changed R1, right? So no need to change. Now paste. Done. Done. The same thing we are going to enable in R2 also. Enable configuration terminal, host name R2. Okay. Same thing we are also going to do. Enable configuration terminal, host name R3. At least we can enable. This is a similar for all the device, right? HTTP, telnet, SSH. We are just enabling in all the device. Okay. R4. Enable configuration terminal, host name R4. Okay. Done. Fine. So telnet, HTTPS, SSH, HTTP, all are enabled into all the devices. Now do the routing into R2. Routing in the sense the interface need to assign the IP into the interface. Okay. So host name no required, no IP domain lookup. This is the IP route. We are doing some default routing towards our in 10.1. Okay. We are doing default route towards firewall here. Okay. Means I am telling to my router, if you don't know the destination, you can blindly send to the 10.1. Okay. Here interface domain lookup, that IP domain lookup, that is why we are using interface 0 by 0. What is the 0 by 0 IP? Not 0 by 0, that should be a 0 by 1, right? 10.100, that 0 by 1. Here we'll use 0 by 1, and here we'll do a no IP route. Here we can do this. Okay. Done. So IP interface brief. So now if you check, 0 by 0 is having, still it is showing as a 10.100. So we need to delete this first. Config terminal interface fast ethernet, fast ethernet 0 by 0, no IP address, for 192.168.10.100 255.255.255.0. So I delete this. Again I came to here. Again I did. Here I need to remove this no. Okay. Then in show IP interface brief. So now this time we assign the IP address here, okay, but still the interface is down. Config terminal interface fast ethernet 0 by 1 and no shutdown. Wait for message. Okay, now it is up. So IP interface brief. So now this is up. Okay, done. In R3 also we need to do the same thing. Here, hello, you are getting everything.
Yes,
Najim,
sir.
all is going good, na? Okay,
I'm getting.
okay.
Yeah.
You getting what we are doing actually? You
Okay.
getting or not? We assigned the IP address still here in the R2, right? Then I
Yes.
did IP route, default route towards. If you don't know the source and destination, you can blindly send to that your next hop like
The
10.1. So
firewall.
to the firewall. Okay, got it.
Yes.
So now you can do the R3, paste it here. Okay, so what we did? IP address 101.1.1 for this one, and second one 102 for the downside. Okay, lens the public user. Done. We did nothing here. Okay, three done. Fourth, what we need to do in the fourth? Because already we enable the what we already enable HTTP HTTPS service already we enabled, right? Now we'll do this in R4. Here also in R4 also we are doing the default route towards firewall. Okay, 20.1 in R4 also. Done. Default route and IP address assigned. Correct. Done. So R1, R2, R3, and R4 is done. The basic configuration HTTPS is configured. Now we need to configure the firewall. So admin. So system interface question mark. So there is no other IP except this DHCP. So config system interface edit port number 2. Set mode static. Allow access ping telnet SSH HTTPS and HTTP. Okay. Set IP 192.168.1.2/24. Next, edit port number 3. Set mode allow access. Set mode is static. Set allow access ping HTTPS HTTP telnet SSH. Set IP 192.168.10.1/24. Done. Here we may okay, that is 168.1.2, correct. So now next another interface edit port number 4. Set mode static. Set allow access ping HTTPS HTTP telnet SSH. Then now set IP 192.101.1.1.100/24. Okay. Then next edit port number 5. Set mode static. Set allow access ping HTTPS HTTP telnet SSH. Done. Okay. Next set IP 192.168.20.1/24. Okay. End. So system interface question mark. So 36. The rest 1.2 here 1.2 here 10.1. Okay. Here 101.1.100.1 means 100. Okay, and second in the fourth 20.1. So all the configuration on is done. Now we'll do 136 IP admin done, not now, later. Okay, now you can check interface. Very first you need to make it as a DSCP or like a manual here. Okay, now rest is done. 192, 168, 1.2, 10.1, 1.100, 20.1 done. Now we'll do RIP configuration. Why RIP configuration? Because there is an RIP, right? 1.1, correct? 10.1, 20.1. So RIP 192, 168 dot what is that? 192, 168 dot 1.1, 1.0/24, correct? Second network which is connected here, 10 and 20 is connected, right? 10.0/24, 20.0/24. Okay, done. Now we need to go to the advanced, and we are just enabling static default route into other routes. Okay, so just enable this static in under like we are doing the redistribution of static routes under RIP, just like we did in last time. under OSPF to EIGRP, right? The same way. Done. Now, now what next? Now check the routing table. Okay, in the firewall itself, get router info routing table details. So this is 101 is directly connected. This is the internet. 172, 10, 10, 4, and 10, 5. It is come from it learned from our IP, right? Which is this one 172, 10, 20, 10, 3, 10, 4, 10, 5 all came from our IP, right? These all 1 and 10, 20, and 101 all are connected directly, right? This is
Yes.
connected directly, right? This 101 is our this side 101 is also learned by RIP, okay? And 159 is also connected. This is the DSCP, so port 1. Then fine. In the similar way, we need to check in the routers also whether this is learn or not. So OIP, so IP route RIP. So from RIP, how many network is learned? 10 and 20. This 10 and 20 has been learned, right? 100 is a not a 100 we can't advertise in the this RIP because it is just an interface IP or the public network, okay, so we can't do that. Go to the R2, so IP route RIP, so IP route, so there is no RIP configured here, right? Any RIP configured here? No, right? Only RIP is configured into R1. Got it? So IP route, there is no routing route learn from the RIP because RIP is not enabled here. Okay, we did not configure RIP routing information protocol. We just did a static default route towards firewall. Okay, 10.1. So this is 10.1, correct? In R3 also, if you check, so IP route here we did nothing. There is even though there is no default route. This S star means default route. Okay, so check the R4. R4 also will get a default route. So IP route. Okay, default route here also towards firewall. Fine. Now if you check the connectivity, there will be no connectivity, right? Ping 192.168.10.1. No connectivity because by default policy is implicit deny. If you check, what is the policy? Firewall policy. Default policy is implicitly deny and action is deny, right? Implicit policy from any source, from any destination, said any time, any service, action is deny. Okay, so no one can reach to each other, right? Now you can create, and if you want to establish a communication, that is fine. But for that, what is our first requirement? Is how many type of network is there? Static net is there. Okay, so we'll do the static net for inside user to access the internet, right? Correct?
Yes, sir.
Okay.
Yes.
So now, just a minute. So static nets are means will map one private IP to with one public IP. Okay. So just assume your manager has sent one message or an email that you just allow to internet access to this particular IP 192.168.1.1, allow this internet access with the by using a 101.1.1 dot 101 means 1 2 3 4. Okay, so 101.1.1.101. So this you just map this private IP with this public IP. So whenever this user will hit to the Google or somewhere, so it will use this IP as a source and it will go to the internet. Okay, clear? And directional, unidirectional or bidirectional. Unidirectional means one way. The traffic will come from here and it will go via like this. Okay, bidirectional means both way. Okay, so the request is unidirectional. Okay, so request as per the manager, it is he asked to make a unidirectional but not a bidirectional. Okay,
Okay.
means one way communication. So start the communication. Start the configuration, create a policy. Before that, we'll do a static default route also for the internet. Okay, let me do that the static route network, because when we don't know the destination, we just always create a 101.1.1.1. Okay, when we don't know the destination, it will go to the internet. Okay, fine. Now get a policy. Go here, create new. Traffic will R1 static, R1 to outside. Okay, static route for R1 to reach the outside. Traffic will come from R2 and it will go via R4. R2 to R4. Right? R2 to R4. Fine.
Yes, yes,
So source will, who will be the source? All or particular this given by the manager 1.1 only, right?
yes,
Create
Mahesh.
here 192 dot, or I can say R1 here. I given the name. Subnet, okay. 192.168.1.1. Fine. Any slash 32 because one IP only. Okay. Done. Who will come? He will come. R1 will come. Okay. And destination will be anywhere it can go whenever you want. Always any service that he can access. Okay. Except flow based, and net must be enabled because we are doing the netting. Use dynamic IP pool. So why we need a dynamic pool? Because our manager asked to create that, right? Use some public IP, right? Use one public
Yes,
IP for this R1, right? CTR, we missed that. Okay, the policy is cancelled, but still if you see in the address, you'll get R1. Okay, so again no need to create. Whenever you're creating address, it will come under this address option. Firewall policy, create new R1 static net. Okay, R1 static net unidirectional. Okay, R1 packet will come from 2 and go via 4. 2 and 4. Source will be all. Destination will be all. Source will be not all. Source will be just R1. Okay, R1. This one, and always services all and use dynamic. So here you need to create the pool. You need to define the public IP by which IP it will go to the outside. So here public static, or we can say manager is asked to 101.1.1.101, right? So we can use an overload or static, because static is means one to one, one private, one public. Okay, which IP? This IP by this IP only. Done. This is just a name. Okay, which IP from this is the range. It is asking for the range. So if you give a single IP, it will not accept. Okay, it will not accept. So you need to use a complete. This IP is starting and this IP is only ending. Okay, that we are defining in, and the type will be a one to one. Done. So in some time, your interviewer will ask, may ask, what is the one to one netting? Okay, so you need to say static net. Okay, done.
yeah,
So now done. Select this one. Okay. So now with this policy, what actually we define? So the traffic will come from R2. Who will come from R2? The this 1.1. Okay, 1.1 will come from the R2 and it will go via R4. Okay, any day, anywhere it can go, anytime it can go. It can access anything. Okay, any service by using this IP. Okay, that we define. Then now policy has been created. Now you can check ping one. Okay, internet, in internet do we have 1.1.1 anything for the configuration terminal? interface loopback 100, IP address 1.1.1.1. Just assume this is internet 255.255.255.255. Okay, done. R1 ping 1.1.1.1. Is it okay? It is getting right now.
Yes, yes,
Okay, it is able to access now. But you can check in the internet. It is coming to internet debug IP ICMP. Who is coming as a source? R1. Check who is coming. Source is a 1.1, destination is 100. Who is sending the request? Request sent via by destination is 101.1.100. So source is a 1.1. It is a reply packet, okay? And the request packet is there. Only reply packet, right? There is no request, right? Echo reply, echo reply. Are you able to see anywhere 192.168? No, right? In internet, no one can see your private IP from where you're coming. It will always show your a public IP, which is our 101.1.1. Okay, clear?
yes, yes,
Yeah. Now let me do because of the static routing, it is going to internet. Okay, because of static routing. So let me delete this static route. Now you can hit the same thing. Okay, to stop this, you all. Now you can hit 1.1. Is it able to reach the internet? No, right? Is it coming?
yes.
No. Like you can check in the packet tracer. Go to the interface. You can do the packet capture. Packet will come from the R2 and it will go to anywhere and by using anything. Okay. So now hit start. Again hit because packet capture was not start. Okay. It is one packet, two packet received, right? Just a minute. Only one packet as of now received. Please mute yourself. Two packet received. Only two packet received, right? How many packets sent? Total four packet. Again hit. It's still going on, right? Now you can stop and you can check, download this, open file. Now you can check our IP version 2 respond 192.168.1.1 send. Destination is it is sending like a multicast IP, right? But it is the wrong one. It should send the ICMP request to that 1.1, but it is not accepting, right? So now you can enable this again, the static routes. Okay. So 101.1.1.101 101 or 1 what is this the next hop IP 1 only 1 then now you can hit now you can again start this again hit the traffic to the this one. So now you can check 13 packet received. Now you can download. Okay, stop and download. Now if you check who is going your 192.168 1.1 where it is going. Destination 1.1, right? It is a request and reply is coming from 192.168 1.1 to whom 1.1.1, right? 192.161.1 and again replace request and reply, right? Means 1.1 is replying. Able to see anywhere in between the firewall you can see the 1.1, but in the internet you can't see. Okay, okay, clear? But internet you can't see. If you want to edit, you can check a port number 4 whether it is coming or not, what is coming what is not. Okay, so again you can hit and again you can start. This is just I'm same time I am trying to explain you the troubleshooting part also. Okay,
Yes.
done. So the 5 packet received. 21 packet receive, stop, download, download. Now, who is requesting? Who is requesting? 101 is requesting, right? Is there anything 192.168.1.1? No, right? Because the private IP is completely hide with the public IP, right?
Yes.
And where it is going? 1.1.1. And who is responding? 101.1.1 is responding to whom? To whom it is responding? No, 1.1 is responding, right? We hop up. This is request from 101. To whom? 1.1. This is reply from 1.1 to whom? 101. Okay, like that. But you can't see your private IP anywhere. Okay, in inside your firewall you can see, but in the internet you can't see. Even the internet user can't see. Okay, so okay, this is able to access the 1.1, but at the same time, is it able to access that anyone from the internet is able to access? Let me check from R3 to access the 192.168.1.1 ping 192.168.1.1. Is it able to access? No, because we don't have policy for, okay, for R4 to R2, means there is no reverse policy, right? Only one way based on our management. The order is like you need to create a one static route in a unidirectional, not a bidirectional, right? So we configure unidirectional. So now this time to allow the static net for inside to outside is done. Okay. Now we'll create a static net for outside to inside. So we'll create here whenever someone will hit to this 101.1.100, it will reach to 192.168.1.1. Okay. One more thing before that, I will ping internet ping 1.1.1.1 from the source. Source, who is source? 172.10.1.1. Is it able to reach the internet? This user 172? No, right?
Yes.
Because we allowed just 1.1 to access the internet. Correct? And
Yes.
remember, in a very rare case, we are allowing this static, using this static net. But when, okay, when you are having a multiple application server which you are hosted into your network, and you wanted to, allow a specific user, or so that time you can define that you can use this static. Okay, fine. Now we'll allow you this inside you outside user to access the inside. Okay, so for that again we need to create a policy. In this policy, the outside user will hit to 100 and it will redirect to 1.1. Okay, create new static net out to in. Okay, traffic will come from the port number 4 and it will go to the port number 2, and who will come? Anyone can come. We can't define, right? Destination, where it will go? Create new. You need to define this, right? You need to define this subnet where it will go. 192.168.1.1, right? Static out in. Okay, by 32, I can just say 32. Okay, anyone can come, and where it will go to this particular destination you can reach from R4. Okay, service, all the service can access. Use dynamic IP pool. So here also we need to create. Okay, by hitting this create overload. So this time also 1 to 1 only, right? A static net out to in 101.1.1.100. Done. So range it is asking. So control C hyphen and control V. So what we are defining, whenever someone is hitting to 101.1.100, this one, the interface IP, it will redirect to 1.1. Okay, static net out. Now, okay, done. So now if you check, now you can, this is the internet, you can hit to ping 192.168 dot not 192, you can hit 101.1.1.100. Is it reaching, right? It is. But check in R1 debug IP ICMP. Who is coming? Who is coming? Anything from R3? Just a minute. If you're not able to do, telnet to 101.1.1.100. So by hitting this, we are able to get the FortiGate, right? But it should redirect to 101.1.100 should be redirect to 1.1, right? So it is again came. Just a minute here. Anything we missed? Stick out to in. All can come. Always, anytime. Static net. So it will external will be a 1.1, right? Create a virtual by people. Create new virtual IP. Check the address first. Under the address, is there anything? Under the policy, the address is there, and check static out to in, right? So it will what we define here. Okay, 192.168.1.1, right? Fine. And is there anything other address? Firewall authentication, static basis VPN. This is the by default one. Okay. Is there any virtual IP pool? No, there is no virtual IP pool. Create a virtual IP pool and give a name. Static out to in. Okay. Interface anywhere it will come. External IP 101.1.1.100, right? When someone will hit this, and where it will go 192.168.1.1, right? Okay. So whenever anyone is coming to here, and whenever anyone is hitting static hours, so here in the policy, what we missed, we need to define the destination. Okay, under the destination, what we are using, we chosen what out to in, right? We chosen this in the destination 1.1, but how it will come? It will not come, right? Because destination we need to define static out to in. Here 101 means whenever anyone is hitting 101.1.1.100, it will redirect to 192.168.1.1. Okay. Now this is the correct policy. Okay. Now you can ask to hit. Now this time you'll get a firewall, not firewall. Now this time you'll get to access of your R1. Okay. Now you can check. Just a minute. Wait for some time. In R3, wait some time. I given one credential here, right? What is the credential? Firewall cafe, and the password is a one secret 123. Secret is a 123, right? So just a minute. If you hit firewall cafe and the password is a 123. So we where we are now in R3, which IP we hitted 101.1.100. What we received? R1, right? Correct? Now again we are in R3 only. Now ping to 101.1.1.100. Hit ping R1. Now R1 is receiving packet from 101.100, right? Correct? And responding to that R3, correct now? It is hitting to 100 and it is reaching to 1.1. Correct? What we are hitted in the R3? 100. Where we are reaching 1.1, right? Where we are reaching 1.1. Clear? Is it clear? So can we proceed further other concept?
Yes, sir.
Okay. So now this static route is done. Okay. Now we'll do the pet. We need to allow multiple private user by using a single public IP. So let's suppose I am having a here I am having a 101 100 anything IP I am having. So I want to allow access internet to all these users. Okay. So this is called as a port paid address transition. So instead of I'm just modifying, okay, we can create one IP address only. Okay. We'll use uh, internet internet paid configuration. I'm just going paid into out. Okay. Incoming will be port number 2, outgoing will be port number 4. Source will be all. Source will define the source. Create new, create all. Address. We can define also like one by one, like 192.168.1.0/24. Okay. This will come. Done. Who is another one? 172.10.2.3.4.5. 172.10.172.10.1.1 1.1/24. Okay. 10.1.0, not IP, network only it will accept. Select, create new address to. I'm reducing the IP address, okay? Otherwise it will take time, so better to I'm just using the 2.3 IP only. 0, 2. Done. So this all can able to access the internet by using the single IP address. Okay. If you want to add any group of users, you can use. Okay. Destination, anywhere they can go. Schedule, always all the services net enable by using the this one. Okay. Or by using the any public IP. Okay. Any IP. Like we can define also. Like just a minute. By using what? We can define the pool also. Which pool? Create new pool. Pet overload. This time earlier we use one to one. This time we'll use overload. Okay. And which IP it will use? 101.1.1.103. Okay. So this IP, by using this IP, this single IP, they can access the internet. Okay. Okay. Done. Pet. Done. Okay. Done. Now you can hit internet from earlier we are unable to access, right, from this 172. Now you can hit the you all ping 1.1.1.1 is a source. 172.10.110.1.1. I'm asking 10.1.1 to hit the internet. They are able to hit the internet, right? Earlier they was not allowed, right? They were not allowed. 2.1, 3.1. Is 3.1 is in our list? Is 3.1 is in our policy? No, right? So the 3.1 cannot access because this is the 3.1 is not in our policy. Our 30.1 is not in our policy. Okay. If you hit 30.1 is there, 10.3 is there, but 10.3 is not in our policy. If you want to add, you can add here, create new, add 30.1, 172.30.10.30.1, 10.172.10.3.0 slash 24, allow. Okay, we missed that 172.10. 30 is missing, right? 172, this 3.0. 3.0 we need to add. We added here, apply. Is it reach or not? Cancel. 1.2 dot. This time 3 dot. 3 dot 172.10.3.0 we need to add here. Close. Now if you add, this one also can reach the internet. 3.1. And who is coming into the internet? Ping. No. Debug IP ICMP. Okay. Debug ICMP. So they are able to reach the internet, right? 101.1.100. Okay. Now the request is coming from this IP. Okay, that we can change. This is our DNS IP for by default from the firewall. Okay. Now you can hit again. Hit. Who is coming? 101.3 is coming, right? and who is responding? 1.1 is responding. That you can also check from the packet capture. Just a minute. Network packet capture. You can reply. We'll capture the packet from the R4 first. Then we can also capture the packet from the R2. So we'll R4. Okay. And is filter. And if you want to keep anything, you can keep host. If you don't, if you know about the source IP, like in our case 172.3.1 is there, right? So we can define 172.10.3.1 is our source. Okay. Protocol, if you don't know, you don't need to mention, but if you know, you can hit. Okay, because the user is coming from here, right? So user is coming from here, but where it is, it will come from. The user will not come from the port number 4. It will come from the port number 1, right? So let me port number 2. Let me do this first. Start, heat again, heat again from here. Heated, started, receive the packet, stop, download. Who is sended the request? 172.10.3.1. Who received 1.1.1? Who reply 1.1 to whom? 170.10.3.1. Here, that is fine. But here, at the same time, if you hit the port number 4 and remove this, okay, just hit. Now again start, again ask to hit, okay. This time see who is responding, who is receiving. Done. 14 packet received, 14 packet received. Stop, download. Now see who is sending. This is the DNS. Leave it this. Just focus in ICMP. Who is the sender now? 101.1.3. 103 is sender, right? And where it is sending? 1.1. Is there anything 172.10.3.1? No, right? So the reply will come to 103, not to 10.3.1, right? Clear? Is it clear?
Yes, yes.
So whatever that static net for in to out, and the pet also we done, right? Port address translation also we done. And how we got to know a port address translation? So here in the source and the destination, right? Source and destination is there, and the protocol, anything like port number by default port number is also there. Okay, length port number should be there. 101. Anyway, I will cover in. Will capture in another packet. So here the port number will should be there. Okay, identification. Anyway. Source IP, destination IP, protocol is there, but port number is missing here. But that should be there. Okay, because in that, by using a single public IP address, we can allow a 64,000 plus users. Okay. Anyway, no problem. Destination port. Okay, leave it. That we need to be start the packet capturing by in the same day. So leave it that. But it's not coming anyway. So that part is done. Now the destination net. We just want to allow outside user to access our inside network. Okay. So we want to allow this user to access our telnet or this both the server. Okay. So what we'll do here, we'll need to create some virtual IP also here again under the policy, firewall policy, and virtual IP is there. Create new like for the telnet. Okay. Which IP they will hit? 101.1.100. 101.1.1.100. 101.1.1.100. Where it will go? It is already in use. Okay. So they will use 104 I'm using. Okay. This time I'm using 104. You can use anything which is not a sign also. That is also fine. And whenever the someone is hitting to your 104, it will redirect to your 10.100. So 192.168.10.100. with which one port forwarding we need to enable? With which port? Telnet. What is the port number of the telnet? 22 or 23?
Telnet.
Hmm.
Telnet is 21, 23, 23.
23. Okay. So whenever someone is hitting 104 with the port number 23, means whenever someone is trying to do the telnet to 104, it will redirect to 10.100. And what is the 10.100 IP? This one, our server IP, right?
Yes.
Done. 23 only. One done. 23. Again clone this. And this time, whenever someone is hitting the 104, okay, with the port number 24, okay, 24, 22 is for the SSH, right?
Yes.
Done. Again, whenever someone is hitting the 104 with the port number 80, 80 means HTTP, right?
HTTP.
So
Yes.
where it will redirect? Where is our HTTP server? Here, right? It will redirect to
Yes.
20.100. Okay?
Yes.
It will redirect to 20.100. 20.100, right? Done. So what we did is telnet and here HTTPS. Here we need to change clone. Instead of clone, we'll do the SSH. Okay, SSH. Here HTTP, HTTP. Here HTTPS also we need to do. We can create clone. Okay, so 443 is a HTTPS. 443, 443.
HTTPS. Yes.
Yeah, right. So we need to change this as a HTTPS. So we need to create the policy once again. Go to the policy. If you check the address, you'll find all these things. Okay, you'll find all these things. Whatever we created now, that you'll get it here. Okay, but in this virtual app, you can't get in the under the address. Okay, so create new. So what will that name? Telnet. Okay, telnet and SSH. I am creating single policy only. Request will come from the port number 4. Request will go to port number 3. Right. The traffic will come from here and where is the telnet SSH server? So connected with the port number 3. Select the port number 3. Who will come? Anyone can come, right? Anyone can come, correct?
Yes.
And where it will go? Telnet selected, SSH selected, services only, a telnet and SSH. Okay, SSH only I'm allowing. Okay, we can define that which can who can come. For the outside user, net is not required. Okay, net is not required for the outside user. Done. But source and the destination. So in destination, where it is 101.104, where it will go 10.100, right? Done. Policy created. Now hit from the internet. Now hit from the internet. R3 ping, not ping. Telnet 101.1.1.104. Okay, we received. What is our firewall cafe is our ID and password is a 123. Where we are now? R2, right? Means this is our telnet server R2, correct? What we hit?
Yes.
104. Where we reached? R2, correct? Correct? SSH hyphen
Yes, right.
L 101.1.1.104. I think what is the SSH command? I forgot, man. Exit. Okay, now we are in already. So SSH hyphen L, right? Hyphen sh hyphen select encryption login using unrecognized command hyphen l word login name firewall cafe incomplete firewall cafe. I forgot this actually how to do the ssh. Anyway, you got to know na that ssh and telnet. mm, www.sh SSS is an established video image. Let me check if anything. SSH root and IP. Okay, okay. Firewall Cafe 101.1.1.104. Now hit. It is asking for the password, right? 123. Where we reached for SSH traffic also it is reaching to R2, right? For
Yes.
Telnet also it is reaching to R2. For SSH also it is reaching to R2 by hitting which IP? 101.4, right? Done. SSH done. Now we'll do the HTTP also. If you hit the HTTP traffic, so for that this is our PC. Let me log in. 123. Hit enter. Hit enter. Close. What is the IP address here? Close. 102.1.1.2, right? Restart later. Just a minute, huh? I'm just holding this. Okay, so we can also make it, 1600. Okay, 1600. Done. Apply. So the screen will be a bigger. Okay, like keep changes. Done. Okay, done now, right? So what we did, we just did nothing. We just assigned the IP address. Now you can check. It is still searching, I think. CMD ping 102.1.1.1. Able to reach the gateway. Ping 101.0.1.1.1. This is 100, right? Where it is 101, not 100. That is a 101. 101. Done, right? So now from this PC we can open any browser, and from this browser we can hit the 104 with the HTTP, so it will redirect to our HTTP server. Okay, so net is not just allow to access the internet, it is also used for the security purpose, which can hide your private IP to the public user or any other user. Okay, and also it will allow a private public user to access your inside by hitting your virtual IP. Virtual IP is, remember, 104 is not assigned anywhere, right? Was it assigned anywhere in the interface? No, right? I did not assign, correct? Hello, hello.
Yes, yes, Hussein.
I was not
Yes,
assigned anywhere, right? The 104 assigned any interface?
yes.
No, it was not assigned into any interface. Look, get router info routing. So system interface. Hit enter. It was assigned anywhere? No, right? Nothing. We are just we just purchase one pool of IP. From there you can use any IP 104, 105, 106, anything, right? Okay, it is taking more than a longer time, but in future if you hit the
Yes, yes,
104, okay, you can get access of your R3, okay? Sorry, you can get of your access of your this R4. R4 means here. If you hit the 104, 101.1.104, it with the port number 80 like HTTP service will come to the firewall. Firewall will send to the 20.100. Okay, because here we given in the virtual IP like 20.100. Whenever HTTP packet will come or HTTPS packet will come by using the 104, it will redirect to 443. Okay. You can use for telnet another IP, you can use for SSH, you can use another IP, another public IP. For HTTPS you can use the 106. For HTTPS you can use the 107. That is not mandatory that you can use the single IP. Okay, okay. If you are having a single IP, then you can use, but if you are having a multiple IP, you can't use that single only. Okay, na? Clear?
yes,
Let me do one more thing here. I need to do remove. Okay, here I'm using one another IP. Which IP? Instead of this 10.0.0.1, if someone is hitting to 10.1, it will redirect to 10.100. Okay, so let me do the telnet. Okay, telnet from R3. R3. Okay, exit telnet 10.1.1.1 or ping telnet 10.1.1.1 10.1 0.0.1, right? 10.0.0.1 10.0.0.1. Are we able to go? No, right? SSH. SSH. Leave it the SSH. Telnet only. 10.0.0.1. We can't access, right? Because this is the public IP. This was the private IP, right? But at the same time, if I use 10.100.1.1.105, I can go to a 10.100. Okay, let me try once again. 100.0.0.105. Okay, leave it now. We'll check it later. Otherwise, again, the confusion will be there. Okay. Anyway, so this is the way how you're going to do. And the telnet, it is taking longer time. You guys can understand what actually we wanted to do here, but it is like 101 dot 100 dot, right? 100 dot 1.1.104. Now hit it with the HTTP. Okay. If you hit HTTP 1001 100.1.1.104, it will redirect to your a system. Okay, the server. Here 104, it will redirect to 104, it will redirect to 20.100. It will take time. In case of anything, if it is not accepting, you can also create a one user. Okay, one user you can create here. User and authentication, user group. You can create a group. You can create a group like let me create a group. Sunil. Okay, Sunil is a group. It will be a part of a, a guest group. Okay, Sunil is a member of guest. Sunil will be a firewall user, not the guest. Sunil will be the firewall user, and I'm just creeping as a. You can create a group of user, local user, user group authentication. Okay, user group authentication you can use here. Next, username Sunil, password is a 123. Next, not now. Next, submit. You created one user Sunil. Close here. Okay. And here you can go to the policy. Under this policy, under this 443 telnet or SSH, you can also allow static telnet SSH pet R1 static, where it is 443 pet 101.4. Who can reach? Was I created anything? Telnet SSH was created. HTTPS was created? No, right? The policy was not created, I think. HTTP and HTTPS. Packet will come from R4. It will go to R5. Who will come? Anyone can come. And who will come with this? The Sunil will come. Okay, Sunil will come. Okay, na? And if you want to allow a particular user, you can allow. But if you don't know about the user, you can keep all also. Okay, all netting is not required because they're coming from outside. Then here, then it is not accepting, right? Try again. Okay, we missed again something. What? Where it will the destination? Destination we need to choose a HTTP. Where it will go? HTTPS and source address will be anything. Destination will be 104. Anything wrong? Still the internet issue here. 102, 102. Let me do 8.8.8.8. Okay, here, here, leave it this. Control panel, network and internet. Something the firewall policy I'm using. Anyway, now we can check. Okay, so this is the way actually might be some, this is not responding. Okay, here. So this is the way how we are going to configure actually. Clear? So HTTPS, HTTP, you can clear like you can configure like this. Packet will come from the port number 4. Packet will come from the port number 5 source. Anyone can come. Destination anyone can reach by hitting the 104. This will reach with the 20.1004. Okay, 100. Okay. So this is the way you need to configure this. Then can we stop now?
Yeah, Mahesh, I think for today we should stop because if you take very long, we're not going to get any
The video will
information.
be also longer, and this is the way only the in the real time it is working, but it is here in my previous chapter also it was not work. So I just tried whether it will work today or not. Okay. Anyway, so this is the clarity all about the netting. So complete net is configured, and tomorrow we'll see you with another topic.